So we are continuing to look at vectors and forces, and the question was, what is the total electric force on Q1? And it's going to feel two forces, one from Q2, which is going to pull it this way, and one from Q3, which is going to push it that way. We found those forces, we found that angle, we did sort of a schematic drawing here, and then we're going to do a nicer drawing here. And I think I'm going to just sort of transfer that onto a brand new sheet of paper because we're going to use the whole thing. And so roughly parallel, so I'm going to say 1.32, I'm going to make that as 13.2, and just sort of get the angle. The overall angle isn't nearly as important as the relative angle. And so this is my force 1, 2, which is 1.32 times 10 to the negative 5th newtons. And now my next force is going to be at an angle of 103 degrees to that force. And it's going to be 10.8 centimeters on my scale. So 10.8 centimeters. It's going to be right about there. And so I've got force 1,3 is going to be 1.08 times 10 to the negative 5th newtons. And so the result of adding those two together is going to be about a little under 19. So it's going to be approximately, force total is going to be approximately 1.9 times 10 to the negative 5th newtons. And then this angle here is going to be about 34 degrees. And we know that this is 103 degrees. Okay, so we've already sort of got our answer, is that if I look that this, I can already sort of tell, I can already give you the answer, but then we're going to do it mathematically. Because I've done a scale diagram, I basically already know what my answer is. That overall, the net force on Q1 is going to be right in that direction. So what direction is that? It's 34 degrees off of this line. So this one's going to pull it down this way, this one's going to shove it up that way. Overall, it's going to head that way. But we can use our good friend law of cosines, and we can say c squared equals a squared plus b squared minus 2ab cosine c. And so we can do c is equal to the square root of 1.08 times 10 to the negative 5th squared plus 1.32 times 10 to the negative 5th squared minus 2 times 1.08 times 10 to the negative 5th, 1.32 times 10 to the negative 5th, and then cosine of 103 degrees. And it looks big and daunting, but my calculator has no problems at all doing this. So I'm going to go all in one line, all in one shot. I'm going to go square root 1.08 second EE negative 5, square that, plus 1.32 second EE negative 5, square that, minus 2 times 1.08 second EE negative 5 times 1.32 second EE negative 5 times cosine 103. Close the parentheses on the cosine, close the parentheses on the square root. Hope it says 1.9 times 10 to the negative fifth. It says 1.88 times 10 to the negative fifth. And actually, you know, when I measured that, I actually did really, really well, because I didn't quite get to 19. And actually, I didn't even quite get to 19.8. And like, you probably can't even really see. But that says 1.88. I'm really happy with how I did there. And then, we're also going to say sine. We're going to say sine of theta divided by 1.08 times 10 to the negative fifth is equal to sine of 103 divided by 1.88 times 10 to the negative fifth. And so we're going to say theta equals sine inverse of 1.08 times 10 to the negative fifth times sine of 103 divided by 1.88 times 10 to the negative fifth. And I'm going to take out that and that because I can. And so we're going to get second sine inverse of 1.08 times sine of 103 divided by 1.88, and we're going to get 34 degrees. So the real lesson that I want to learn from this: a lot of students that I've had have been resistant to doing scale diagrams, to getting out your ruler and your protractor and actually measuring angles, and drawing things to scale. But there's a huge benefit to that, which is that if you know how to use your protractor and you know how to use your ruler and you can make these scale diagrams, you can actually basically get the answer just graphically. You can measure the angle, you can measure the length, and you can do it without having to use the mathematics. And of course the mathematics sort of backs you up on that, but again, a scale diagram will always help you learn the physics. So okay, back with 4 charges in a second.